Imagine spending like years patiently mentoring junior developers to build a world-class game engine. You have these established coding standards, a tight-knit community,
A
and
super reliable pipeline for reviewing contributions, right?
exactly. And then suddenly your project is just nearly destroyed in a matter of weeks by this perfectly formatted, completely confident, but entirely useless automated code.
It's wild. It really forces a massive reality check on what uh, we consider to be technological progress. I mean, when automation scales up the noise instead of the signal, the whole system just grinds to a halt.
Well, welcome to today's deep dive. If you are listening to this right now, you are probably trying to figure out how to navigate this exact shift in your own work.
Yeah, you see the massive promises of artificial intelligence on one hand, and then the increasingly frustrating realities of actually using it on the other.
Right, and you're just wondering what the ground truth really is.
Well, we are going to cut through the noise for you today. We are pulling from the raw data of academic researchers, corporate strategy playbooks, and the literal front lines of open source development.
And the synthesis is just essential for you right now. In an age of extreme information overload, especially when there are, billions of dollars of marketing capital driving the narrative, critical thinking is your absolute best defense.
Absolutely.
We have to constantly interrogate our underlying assumptions. Because, just because a system generates 1,000 lines of code in 2 seconds does not mean it is objectively better for your specific workflow.
Okay, let's unpack this
Yeah.
because we really have a lot of ground to cover. We are looking at a massive ArcSFIF paper from May 2026, Dissecting AI Metrics, a highly practical 2025 Business Insider strategy piece.
And we're going to look closely at the recent crisis within the Godot engine community. Yes. As well as some brilliant, actionable workflows from developers Simon Willison. So our mission is to move past the hype, examine the very real friction these tools are causing for developers, and give you a rigorous system to manage the chaos.
It requires looking at the entire ecosystem, really, starting from the theoretical heights of how these models are evaluated, all the way down to the messy human reality of integrating them into a live code base.
So let's start right at the top, looking at how these tools are actually sold to us. If you pay any attention to the tech space, you are just relentlessly bombarded with leaderboards.
Oh, constant leaderboards.
Right. You see an announcement that a new model just scored a 98% on the human evil test, or it beat a rival model by 2 decimal points on some advanced logic benchmark.
Yeah.
It creates this illusion of absolute, undeniable scientific certainty.
We can call that the benchmark illusion.
The benchmark illusion, I like that.
Yeah, we are deeply conditioned as humans to look at a bar chart, see one bar slightly higher than the others, and just assume we are looking at an objective, universal measurement of intelligence.
But the May 2026 ArcSys paper we are digging into today completely shatters that illusion. The paper is titled Unsteady Metrics and Benchmarking Cultures of AI Model Builders, and the sheer scale of the data they analyzed is just staggering.
They did not just look at a handful of tests.
No, not at all. They analyzed 231 different benchmarks. And this was across 139 different AI model releases.
What's fascinating here is the sheer fragmentation revealed by those numbers. I mean, think about the mechanics of that.
Yeah.
139 models are using 231 completely different ways to measure their own success.
Wait, but shouldn't a benchmark be, an objective ruler? It sounds like these companies aren't using a standard ruler at all. They're just rummaging through a box of 231 funhouse mirrors to find the specific one that makes their AI look the tallest.
That is a highly accurate way to visualize the industry right now, actually.
Funhouse mirrors.
Exactly. The researchers found there is almost zero standard comparability between how different models evaluate themselves.
Okay.
And to understand why, we really have to look at the corporate mechanism driving it.
Right, the money.
The money. You have massive tech giants and well-funded startups that are financially obligated to show continuous hockey stick improvement to their venture capitalists. But the reality of software development is that models inevitably plateau.
So what happens when they plateau on the standard tests?
They simply abandon the standard test.
Oh, wow.
Yeah. If your new model doesn't show a massive leap on standard Python generation, the marketing team doesn't just accept defeat. They scour the academic landscape for a highly obscure niche test.
Like what?
Maybe something measuring multi-step logic and translating outdated Fortran code. Right?
Yeah.
And then they proudly announce they are the new state-of-the-art on that specific metric. So the researchers concluded that these benchmarks are no longer scientific measurements. They are functioning primarily as narrative devices.
Narrative devices. So they are basically marketing campaigns dressed up in academic formatting.
Precisely. They exist to build momentum, not to reflect practical utility.
Man, this brings us right to the 2025 Business Insider article we're pulling into the deep dive today. Their advice for engineering teams looking to adopt these AI tools is incredibly grounding.
Very much so.
They essentially tell leaders to aggressively ignore leaderboard status. Like, you cannot choose an AI model because it has the highest score on an obscure reasoning test. You have to select models based on the exact problem you were trying to solve in your localized environment.
Because a model trained to ace a self-contained 50-line algorithm test in a vacuum will often completely choke when you drop it into a 10-year-old enterprise Java codebase.
Right, the one that has massive undocumented dependency trees.
Exactly. The theoretical top speed of the model is completely irrelevant if it fundamentally cannot navigate the terrain of your specific architecture. Practical utility has to trump the marketing narrative every single time.
So if the metrics driving the industry are essentially this curated marketing narrative, what is the actual collateral damage when developers believe the hype and just plug these bots into live collaborative environments?
A mess.
You would assume that highly rated state-of-the-art models would lead to seamless automation, right?
You would assume that, yes. But the reality on the ground is that injecting a high volume of low-context AI code into a complex social system does not create automation. It creates massive cultural friction.
Here's where it gets really interesting. We need to talk about the Godot engine.
Yes.
For context, Godot is a massive, incredibly popular open-source game engine used by developers all over the world. It is built and maintained by a very dedicated community, and recently they had to make a drastic, highly controversial decision.
They outright banned AI coding agents from their platform.
They literally had to build a wall to protect their ecosystem, and analyzing their reasoning is crucial for you, the listener, because it directly challenges the prevailing Silicon Valley assumption that more code generated faster is always better.
Exactly. They didn't ban AI because it was writing code that was too advanced. They banned it because the flood of AI-generated pull requests, the submissions of new code, was actively demoralizing to their core community.
Right, people were firing up AI tools, generating massive amounts of code to fix minor issues and submitting it to the project.
The code lacked any broader architectural context.
I was trying to picture what this actually feels like for the senior maintainers reviewing these submissions. It feels like a master chef trying to patiently teach a culinary student, right?
Yeah.
But then a robot just keeps aggressively throwing perfectly diced but totally random onions into the pan.
Just random onions.
It ruins the lesson, right?
That analogy hits the core of the problem perfectly. If we connect this to the bigger picture, we have to understand the mechanics of open source development. We tend to view open source as a free code factory, a place where software is just anonymously manufactured. But it is, in reality, a highly delicate social ecosystem.
Built on trust.
Yes, it relies on a carefully managed pipeline of human mentorship and trust. The robot throwing onions doesn't care about the recipe, it only cares about delivering onions.
Right.
In the Godot community, the traditional model relies on a senior maintainer reviewing a novice's code. They check for memory safety, backward compatibility, and alignment with the project's specific style guides.
And they give feedback.
Exactly. And over time, that novice learns the nuances of the architecture and becomes a reliable core contributor themselves. It is a slow investment in human capital.
But when an AI agent dumps a massive, complex, but subtly flawed piece of code into the system, that investment pipeline completely breaks down.
It does.
The AI does not learn from feedback. It does not care about backward compatibility.
And that means the senior maintainer is no longer mentoring a human who will grow to support the project. They are abruptly forced into the role of debugging a machine's localized hallucinations.
Which has to be exhausting.
It completely drains the cognitive energy of the volunteers. It transforms their identity from community leader and architect to basically a garbage collector for automated spam.
Wow, garbage collector for automated spam. That is the true cost of the benchmark illusion right there. Godot had to ban it because the frictionless generation of code was threatening the actual human infrastructure that maintains the software.
Exactly.
So AI code is flooding the zone, and major open source communities are putting up walls just to survive the onslaught. But let's bring this directly back to you, the listener.
Right.
You are probably not running a massive open source game engine. But you almost certainly want to use AI coding tools in your daily job to get an edge.
Of course.
How do you integrate these tools without creating that exact same demoralizing, unmanageable chaos for yourself or your engineering team?
Well, you cannot just plug the tool in and expect it to manage itself. If you want to extract actual value out of inherently chaotic, probabilistic systems, rigorous structure is absolutely required.
And we found a highly actionable answer to this in a recent piece from the Stack Overflow engineering blog.
Yeah, that was a great piece.
Their core thesis is that you have to turn AI coding chaos into a repeatable playbook. They argue that developers must move completely away from freeform prompting.
Which is where you just open a chat window, describe your problem, and hope the AI spits out the right app.
Right, away from that and move towards strict checklists and constrained processes.
It is the necessary transition from vibes-based development to disciplined software engineering.
Vibes-based development, that's so true.
To understand why freeform prompting fails, we really have to look at how large language models work on a mechanical level. They operate on probabilities, predicting the next token.
Right.
When you give an AI a massive, open-ended prompt like build me a secure login system, the probability space is astronomically large.
Millions of paths.
Exactly. It has millions of different ways it could resolve that prompt, which practically guarantees it will hallucinate dependencies or mix up design patterns.
So the playbook constrains that probability space.
Drastically. You do not ask for a login system. You follow a checklist. Step 1. You command the AI to only generate the database schema and absolutely nothing else.
Okay.
Step 2. You, the human, review that schema for security flaws. Step 3. You prompt it to run the database migration script based strictly on the approved schema.
Nice and locked down.
And then step 4. You prompt it to build the front-end components. By breaking the task down into verifiable micro steps, you drastically reduce the AI's ability to hallucinate.
But hold on, isn't the entire utopian promise of AI that it does the heavy lifting for us? I mean, if we have to sit down, design a rigorous step-by-step checklist, heavily constrain the AI's output, and micromanage every single piece of code it generates just to keep it on track, aren't we just replacing the actual fun, creative work of coding with the incredibly tedious work of middle management?
I challenge that premise completely.
Really?
Yes. We have to separate the physical act of typing syntax from the actual discipline of software engineering. Typing boilerplate code into an integrated development environment was never the truly valuable part of your job.
That's fair.
The value you provide is system design, architectural resilience, and ensuring the software solves the human problem without breaking existing infrastructure.
So you are saying the definition of a developer is fundamentally changing?
Yes.
Entirely.
You're transitioning into management, but you are managing a junior developer that can type 1,000 words a second.
1,000 words a second.
Yeah. And if you do not provide the architectural guardrails, that sheer speed becomes highly destructive, as we saw with Godot. The playbook is not tedious middle management. It is the new essential technical skill.
Because without it,
if you try to use AI without a playbook, you will drown in code you do not fully understand, written by a machine that doesn't care if it works.
okay, that makes a lot of sense. We know we can't fully trust the benchmarks because they're narrative devices. We know we don't want to cause the architectural collisions the open source communities experienced.
Right.
And we know we must build a strict playbook to constrain the AI. But what does a truly great playbook step look like in practice? How do you actually ensure the AI isn't just lying to you with incredibly confident sounding but completely broken code?
This brings us to the core concept of verifiability. A robust playbook must have a mechanical way to prove that the code functions before the human ever spends cognitive energy reading it.
And this is where we turn to the brilliant work of developer Simon Willison. He has been documenting his workflows on his blog, specifically using an experimental tool he built called Lelm Coding Agent 0.1A0.
And he shared a highly practical approach to verifiability that is just incredible. His pro tip is this: force your AI agent to record a video demo of its own work before it shows you the code.
That is so smart.
It is a phenomenal inversion of the traditional burden of proof.
So what does this all mean for you? Think about how much of your day is spent just reading code to see if it makes sense.
Hours, usually.
Right. If an AI writes a script to build a web dashboard, you normally have to read through hundreds of lines of hallucination-prone syntax to guess if it functions. Or, you have to download the code, install the dependencies, spin up a local server, and click around yourself.
It takes so much time.
Exactly. But Willison completely bypasses this using an automated command line utility called ShotScraper.
Let's break down the mechanics of how this actually runs, because it is fascinating. He doesn't just ask the AI for code. He gives the AI agent access to a sandbox terminal environment. He commands the LLM to write the HTML and JavaScript for the application. But the playbook doesn't stop there.
Right, the AI then has to write a bash script to spin up a local server hosting its own code.
Exactly. And then, using ShotScraper, which is essentially a headless browser automation tool, the AI is instructed to open the web page it just built, interact with the elements, record an MP4 video file of that interaction, and save it to a directory.
It's the ultimate picks or it didn't happen rule for artificial intelligence.
Yes.
I love this so much because it forces accountability. You don't just tell me you built the calculator application. You show me an MP4 video of an automated mouse clicking the buttons on the calculator and the numbers adding up correctly on the screen.
Consider the structural impact of that workflow. It solves the exact problem the Godot maintainers were suffocating under. Instead of forcing a human expert to expend their highly limited time reviewing a potentially broken submission, you force the machine to visually prove its output works. You review the 10-second video.
And if it's broken,
If the video shows a broken layout or a failed calculation, you reject it instantly. You only invest your time reviewing the underlying code after the AI has proven the application functions.
that's brilliant.
It puts a hard, verifiable checkpoint in place that completely insulates the human from the chaos.
That is such a practical, immediate upgrade that anyone listening can start building into their workflows today. You are literally taking back control from the machine. So let's pull back and look at the entire journey we've been on during this deep dive. We started by looking at the raw data and realizing that those flashy AI leaderboards are often just narrative devices.
Right. Corporate marketing tools designed to secure venture funding, rather than objective reflections of utility.
We then explored the tangible human cost of believing that marketing hype blindly. We looked at how the Godot open source community had to literally ban AI tools to protect their delicate architecture and their culture of mentorship from being buried under a flood of low-context automated pull requests.
And finally, we discovered how you can integrate this technology safely.
Yes.
By recognizing that typing is no longer the bottleneck, by embracing your new role as an architectural manager, by building rigorous, step-by-step playbooks to constrain the AI, and by demanding undeniable, verifiable proof like an automated video demo before you ever trust the machine's output.
It really represents a massive paradigm shift in how we build things.
It does. And it leaves me with one final lingering thought for you to take away and mull over today.
Oh, I'm ready. Let's hear it.
This raises an important question. If AI benchmarks are mostly just marketing, and integrating AI safely into our production environments requires us to build these strict structural playbooks and demand video proof of its work.
Yeah.
Is the future of human programming less about writing software and entirely about becoming an auditor of machine behavior?
Oh, that is a heavy thought to sit with. Are we all destined to become auditors, constantly demanding proof from our digital apprentices?
It's very possible.
It really fundamentally changes how you look at your own career trajectory in this landscape. Well, that is all the time we have for today's deep dive. Thank you so much for joining us, for challenging your assumptions, and for learning alongside us. Remember, in a world moving this fast, there's always more to learn. Keep questioning, keep exploring, and we will catch you on the next deep dive.